Good morning and welcome back. Today we are going to continue on in Chapter 2. We're starting off with some inductive and deductive reasoning, talking about what those mean, and then moving into something called algebra proofs. Okay, so if we look here at our definitions, inductive reasoning is the process of reasoning that a rule or a statement may be true by looking at specific areas. Okay, so for example, maybe based on our past experience, when the sky is dark, we know that's usually an indication of rain. So we could say something like, "I think it's going to rain because the sky is dark." Um, but if we think about it, that is not factually always going to happen, right? Sometimes it may be true. Sometimes there's clouds. Sometimes it just might be nighttime. Okay, so inductive reasoning kind of going based on previous things that we've seen to be true, or previous cases we've seen. Okay, where deductive reasoning, this is the process of using logic to draw conclusions. Okay, we use facts, definitions, postulates, theorems to prove that a statement is true for all cases. Um, so, if we look down here, if Rebecca's shopping for a new phone, she sees some reviews. We want to know which of these could be inductive reasoning, which is deductive. So this first one, this is a great phone. I have 3 of these phones, and each one works amazingly. Okay, so Cat123 definitely going on past experiences. Her phones have worked, so she's assuming they all work. So this would more be inductive reasoning. Sunny says, this phone doesn't stay charged as long as other phones. It has a smaller battery according to the specifications. I wouldn't buy this phone. Now, it has a smaller battery according to the specifications. She has not stated exactly what the fact is, but we know that she is going based on the fact she looked up the battery and it is smaller. So that's going to be deductive. Okay, she's going based on the facts. Number 3 here, Shauna B. I would not recommend this phone. I know 4 people that bought it and each had troubles. Okay, that's definitely based on previous experience. Not her experience, but someone else's. Juan Car Guy, this phone is the perfect size to fit into a pants pocket easily. I checked the size before I bought it. I have told all of my friends to buy this phone. Okay, this one you could probably argue either way. It says he checked the size before I bought it. Now, does that mean he just kind of looked at it? He actually looked up. If he looked up the size and knew the exact size of his pocket, then that would be deductive. If you just kind of reasoned and said, well, that looks about the size of something that would fit in my pocket, then that's inductive. And finally, everyone in book club has this phone. They all say it's the best phone they've ever used. That's inductive. Okay. So remember, inductive, we're more kind of just reasoning based on past experience. Deductive, going based on the facts. Now, today on your Delta Math, when you do the assignment, it's going to ask you to choose between inductive or deductive for the questions. It's not like it's always been before. You don't have unlimited options, okay? It's a yes or a true or false question, essentially. Well, you have 2 choices. So whichever one you choose, double check yourself because you only get 1 attempt at them, okay? You don't get a new question. So today's Delta Math is a little different in that you don't get unlimited attempts. Now, on the questions like this, you will get 2 tries if you miss it. So, use algebra and deductive reasoning to justify this statement. Now, we're going to do this through something called a 2-step proof. So, when we have a 2-step proof, we're going to have a 2-column proof, not 2-step, 2-column proof. So, we're going to have 2 columns. One is our statements on the left side, and then our reasons on the right. All right, and our first statement is always going to be what was given to us. So 3x plus 8 equals negative x. We're just going to state the problem. 3x plus 8 equals negative x. And the reason we know this is it was given to us. It was on the paper. Or I gave it to you. Or someone else gave it to you, right? Okay, now, if we were solving this, just an algebra problem, once again, the reason we're doing this, we want to get good at 2-step proofs on something we already know how to solve. You guys know how to solve this problem. So we're going to practice doing 2-step proofs. Sorry, I keep saying 2-step proofs. 2-column proofs. Because that way, when we get to geometry, stuff we aren't as good at, we will be good at 2-column proofs. We'll just have to figure out the geometry part of it. So to solve this, you would probably want to move this x. There's a couple ways you can do it, a couple different orders, but I want to move that x over here. And to do that, we need to add x to both sides. So if we think about it, 3x plus x, right, because we're going to add it to both sides, equals negative x plus x. We add it to both sides, and that's just addition. Now, technically, you should probably put property of equality. As you can see, our properties here, the addition property of equality, when we add something to both sides, the same thing to both sides. Subtraction property of equality, we subtract the same thing from both sides. Multiplication, we multiply both sides by the same thing. Division, we divide both sides by the same thing. But I'm not going to make you put property of equality, so addition is fine. Okay, now we're going to combine our like terms. So 4x plus 8 equals 0, and that's because we're simplifying. And at this point, we need to move the 8 over. So 4x plus 8, if we subtract it from one side, then we'll subtract it from the other. So that's our subtraction property of equality. So 4x equals negative 8 if we simplify. And now our final step is we will want to, well, I guess second to final step, we'll take what we have and we'll divide both sides by 4. And then our last step, that will be simplifying, right? So division property of equality, okay, division. And then our final thing, we're going to simplify it to get it to x equals negative 2. All right. So we started with something we knew how to do. We could all solve this. You probably wouldn't use this many steps. You wouldn't explain it in this many words. The goal is if someone walks in from outside the class, they should be able to look at this and know exactly what we have done and why we've done it. So here, complete this 2-column proof. We are told that ST equals 23. Right here, we see that 23, or ST is also equal to 14 minus 5, so we can set those equal. That's given to us. Now notice they add 5 to both sides. If we add the same thing to both sides, that's the addition property of equality. Then from there, 4t equals 28. They simplified. Then we divide both sides by 4. So division. Ooh, that was a bad letter D, but. And then we simplify to get t equals 7. All right. Our final one here, final one of the day. We're writing a 2-column proof for this to prove that x equals 7. So this was given to us. We always start, remember, with our given here. And now there's 2 ways you could solve this. Okay, either way is fine. You could either multiply or add first. It does not matter to me. I'm going to add first because I think lots of you would choose to do that, but I don't care which way you do it. If we add it to one side, we have to add it to the other. Now when we add this, on the left side it's pretty easy. It cancels out and we're left with 1/4 x. The right side, 1 plus 3/4. You could write that as a decimal, or you could write it as a mixed number, 1 and 3/4. We're going to write it as an improper fraction, which means if we think about it, we take 1 times the denominator, so that gives us 4, and add it to the numerator, so 7. So 7/4. And that's simplified. Now the reason we did that is because that allows us then just to multiply both of these by 4 and easily see those will cancel out. So multiplication, and those will cancel out, and we're left with x, or 1x equals 7. All right, that's all I have for today. Please check out the Delta Math. Give that a go. Hope you guys have a great day, and I'll see you guys later.